I am Professor Manish Singh. I am just going to deal with the discrete mathematics and graph theory for coming sessions for your GATE. If we'll see the weightage of the marks in GATE examination, earlier it was for 5 marks in GATE examination. But now, earlier mathematics portions was a bit lengthier than this year. Now the syllabus has been changed for your GATE examinations, and now some portions of the mathematics they have removed, and total mathematics is going for 15 marks. So if some portions of the mathematics they have removed it, automatically the weightage on the discrete mathematics will go up. It means earlier it was a 5 marks, now it will be 7 to 8 marks. Minimum this marks is going to be for your GATE point of view. So this subject has become more important for you. In coming of the sessions, we will be taking all the topics in detail with all the problems of the previous GATE examinations, as well as I will feel very delighted that you will ask some questions from your chat box. We will take all your doubts and we will try to learn the subjects in very detail so that it will be helpful for us in GATE examinations and it will make us clear the exams. If you have any kind of a doubt, you can directly write into the chat box. Now, if I'll go for this one, what happened? I'll just try with the fundamental of the subjects and then we'll start with this one. Now we are talking about the discrete mathematics. Discrete maths. If I'll see for the syllabus of the discrete mathematics, it will deal with the set theory concept. Set theory. Then it will go for mathematical logic. Mathematical logic, part 1 and part 2. This chapter has been converted into 2 parts. First part will be with the quantifiers and the second part will be without quantifiers. I'll be seeing the details in later half. Now, the next topic of this one, we are going to deal with the functions and relations. Functions and relations. Now, next one we have combinatorics. Combinatorics means counting kind of a problem. What kind of a counting we have, that all the counting problem means we can directly overall we can call combinatorics. Combinatorics. Now, next topic we have groups. And then lastly, we have a graph theory. We have a graph theory. This is the complete syllabus of your mathematics, discrete mathematics, and it will be weightage. Earlier it was for 5 marks, now the weightage are of 7 to 8 marks minimum. If we'll go for the one by one the topic, today I'll be starting with the first topic, that is called set theories. We'll be starting with the set theories. This chapter is very important for your concepts clearance of the latter half the things, that is function, relations, groups, everywhere, combinatorics, all the concepts is based upon the set theory concepts. Before I go for the set theories, firstly I'll ask one thing. We are learning discrete mathematics. It is discrete one. Discrete maths. Now, if I'll ask it, why this discrete mathematics is only for the computer science students? No other engineering students are learning this subject, and we are learning engineering mathematics as well as we are learning discrete mathematics. A bit different with that discrete. What do you mean by discrete and how this mathematics deals with the previous one? Engineering mathematics, what we are talking about. What do you mean by discrete maths? Yeah, just see here, discrete mathematics we are talking about. Discrete maths means discrete, a word is there called discrete. Discrete means distinct or unique. unique. Discrete means absolute value, unique value. I'll give one example. Let us suppose in our classroom, if I'll ask for the distinct value, if I'll ask you number of students in the classroom, number of students in the class at any time. Let us suppose at 6 p.m. I am asking, so in my class, let us suppose either it will be 10 students or it will be 9 students or it will be 8 students. It can't be in a fractions. Or the answer won't come, sir, it can't be calculated or we can't find it the values. Answers will not come like that. If this is the question, number of students in the class, a distinct value will come, discrete value or absolute value will come. Let us suppose 5 people are sitting in my class and after some time one can go out. Then my answer will come 9. But we can say the answer is 9. It is not, it won't come 9.5 or 8.999 or something which we can't predict the values. It will be always distinct. Rather, versus of discrete mathematics, I'll go for a discrete opposite versus it is going for a continuous. Continuous, I'll give one example. Let us suppose it is raining outside. Nobody in the world can teach or tell what time, how much rain has came on the earth. Nobody. Even though we have so many of measures, but we can't define it. What is the level of water has came? It will be just approximate value and within some certain timing frame. Another example. Let us suppose if you are belongs to the nearby at any river is there or somewhere, if you'll ask what is the water level at a dam at a particular time, nobody can define it. Let us suppose some civil engineering people are telling, sir, water level is 3 mm, they are 3 cm, 3 centimeter water level is there. But let us suppose at the same time, at that dam you are putting another hundreds of buckets of water. Will the answer will change or not? Answer will come, no, it is not getting changed. But if my question is, if not getting change, where that 10 liters of water has gone? Or forget about that 10 liters, if I am putting thousands of liters of buckets of water, answer will be the same, because at a dam it is a very huge quantity of water it is. So it is a continuous function. We can't find exact value unless it is a measurable on a scale. Let us suppose we have a centimeter, we have mm, we have smaller scales we have. But if 1 lakh part of this one, we can't measure it. At the same time, if I'm asking for a fraction of the time minimum criteria is for the seconds. Time minimum criteria is the seconds. 1 second minimally we can call. But what if I'm talking about 1 by 1000 seconds? Can we measure that time in our life? Of course not. Or forget about the thousands. If it is, I'm talking 1 by 1 lakhs of the time, second, we can't measure it. But even though that fraction of time also is happening in our life, that is called continuous events. Every fraction of second, something is getting changed and we have to get that values. That is called continuous events. Raining, it is continuous event. Unless it will rain for some time and it will be on a measurable scale, we can't find it, how much level of water has came. Another example. Let us suppose at your room, some temperature will be there. If you will just switch on your AC, will it, let us suppose at the starting it is 22 degrees centigrade, room temperature. And if you are just putting a light on that or you are putting AC on that, to make it to the 21 degree, I want to just reduce this temperature. Will the AC will make it within a second? Of course not. Of course not. But it will be continuously, it will be keep on changing the room temperature, and unless it will be a fraction of measurable scale, it is going, we can't find it. So it takes some time to make 22 degree to 21 degree, and in that fraction of second we can't find how much temperature has cooled down. So that is called continuous events. Another example. Let us suppose at your home one small kid is there. If some kid is there, day 1 his height will be something. Let us suppose I am taking 1 by 2 meter. His height is at day 1 you are talking, once you are studying measuring, his height is 1 by 2 meter. And after some certain months, or let us suppose later, after 1 year, his height is going to be 1 by this meter, 1.5 meter. When this has happened, can you measure it? When his height has been incremented from half meter to this one? Nobody. Let us suppose you are measuring his height every day. Early in the morning you don't have any job. You are just measuring with scale. Measure it. How much height has been increased? You can't find it when that this height has converted to this one. Any of the point of the time you will be not finding any differences. But this increment has been happened. This increment has been happened. But we can't measure it. That is called continuous events. At a certain point, small increment is occurring which we can't measure it. It is asking for 1 meter I am talking about. So meter, we have a scale in meter, we have a scale in centimeter, we have a scale in millimeters. Less than that increments. Let us suppose a child is not getting 1 centimeter increment every day. He is getting increment 1 by 10th of millimeter. That can't be measured. Small fractions, height every day he is gaining. So if you will go for a 1 month changes, we can find, let us suppose 1 mm. That is measurable in our scale. So at a particular point we can't measure it, but if you will give some time frame, we can measure it. So that is called continuous events. So that we are going through the normal engineering mathematics calculations, where let it be unique values are not coming at every particular moment, but some values are coming. And accordingly it is getting incremented. That is called continuous events.